All right, let's jump into some pretty cool AI research today. Um, it's all about making AI models even smarter, especially when they have to handle tons of information.
Like a fire hose of data.
Yeah, exactly.
Yeah.
You know how sometimes you try to remember everything from a long article
Mm,
or like a really detailed report? It can get kind of overwhelming.
right.
It's like your brain is overloaded.
Totally. AI actually has similar struggles when it comes to long sequences of data.
And that's where this new research comes in. It's a paper by Yu Zhang and their team, and they've come up with this new approach. It's called gated slot attention.
Or GSA for short.
Yeah, GSA.
Yeah.
It's all about helping AI models learn and remember better without getting, bogged down by all that information.
So it's giving those AI models a more efficient way to study,
Yeah.
instead of trying to cram every single detail, they focus on what's really important.
So the paper starts by talking about the problem with the way a lot of AI models work right now, especially these things called transformers.
Right. Transformers have been like the go-to architecture.
Yeah, and they use this thing called attention. But it gets really complicated when you're dealing with these long sequences of data.
Yeah, it gets computationally expensive.
Yeah, they call it quadratic complexity.
Yeah, you can imagine if you were trying to connect every single word in a 1,000-page novel to every other word.
Oh, wow.
It's just a massive computational nightmare.
So that's what traditional transformers face with long sequences.
Exactly.
So how does GSA, handle this?
Well, one approach that researchers have been trying is something called linear attention. It's kind of like taking that massive novel and summarizing it into just a few bullet points.
Okay, so it's simplifying things. But doesn't that mean losing a lot of the details?
Yeah, you're right. There's always a trade-off. It
Yeah.
makes things more efficient, but you might sacrifice some of that recall, especially when you're dealing with those really long sequences.
I see.
It's like if you were trying to understand a complex historical event just from a timeline,
Right.
you'd be missing out on all the nuances and the connections.
Right, you'd miss all the juicy details.
Exactly.
So we've got this kind of classic dilemma, right? Efficiency versus detail. How does GSA find a better balance?
Well, that's where things get really interesting. GSA actually builds on this idea called attention with bounded memory control.
Bounded memory control.
Yeah, or ABC for short.
Yeah.
And it's kind of like if you imagine a really super organized librarian who knows how to shelve books super efficiently.
Right.
Instead of giving every single book its own space, they might group similar books together.
To save space.
Exactly. And this is similar to how our own brains work with memories.
Oh, that's interesting.
We don't remember every single detail of every experience.
Yeah, we prioritize.
Exactly. We focus on the key things, the important stuff.
Yeah.
And GSA kind of takes this idea a step further. It adds this forgetting mechanism.
A forgetting mechanism, so it forgets things.
Well, not exactly. Before you picture a robot with amnesia,
Okay.
let me explain. What this forgetting mechanism does is it helps the model prioritize information, just like our brains do.
So it's like the librarian decides, okay, this book is outdated, we can archive it.
Precisely. GSA uses these things called gates to control what information gets retained and what kind of fades into the background. Just like our brains tend to focus on recent events while older memories become less vivid.
That's a really cool analogy. I'm starting to see how this GSA manages to be both efficient and good at remembering.
Yeah, and it's this ability to selectively retain and forget information that makes GSA so powerful.
Right.
If you dig into the technical details, the paper describes GSA as a two-pass gated linear attention process.
Two pass. So is it like reading that novel twice?
You could think of it that way, yeah. The first pass is like getting the gist, and then the second pass is where it focuses on the really important parts.
Okay, like highlighting or underlining.
Exactly. And this two-pass approach allows GSA to make much smarter decisions about what information to keep and what to let go of.
To use its limited memory slots wisely.
Exactly.
This is getting pretty fascinating. But the real question is, how well does GSA actually perform? Does it actually live up to all the hype?
Well, the paper describes a bunch of experiments where they really put GSA through its paces.
Oh, cool.
They compared it to other state-of-the-art models, and, spoiler alert, GSA did really, really well, especially when it came to tasks that required remembering stuff from, like, way back in a long sequence.
Okay, so it aced the test.
Pretty much. One task they used was this thing called multi-query associative recall, or MQAR.
MQR go.
Yeah. And imagine, like, trying to search through your email archive for every message related to a specific project, even if those messages are scattered across, like, months and months of emails.
Ooh, that sounds painful.
That's kind of what MQAR is testing.
So how did GSA do?
It really excelled. One of GSA's big advantages is its ability to handle long-range dependencies. So it's not just about remembering individual pieces of information, it's about understanding the connections between them.
Even when they're far apart.
Exactly. Think about understanding the plot of a movie. You need to remember what happened earlier to make sense of what's happening now.
Right.
GSA is really good at that. And the paper shows that it consistently outperforms other models, especially those that use linear attention. When it comes to grasping those long-range connections within a sequence, it's pretty groundbreaking for tasks where understanding the context is super important.
That's impressive. But I have to admit, when I first saw the equations in the paper, my eyes kind of glazed over a little bit.
Yeah, it can get pretty mathy.
Can you maybe break down how GSA actually works on a more intuitive level?
Sure. Remember we were talking about those memory slots being like containers for information?
Mm-hmm.
Well, you can imagine each slot as holding a vector, which is basically a set of numbers that represents some aspect of the information.
So if we're sticking with the novel analogy, it's like each container holds a tag for each character, listing their key traits or their relationships to other characters.
Exactly. And every time GSA encounters a new piece of information, it uses linear attention to calculate a set of weights.
Weights?
Yeah. These weights determine how much attention the model should pay to each of those memory slots.
Okay, so it's like deciding which containers are most relevant to the new information.
Exactly. But here's where GSA gets really clever. It uses those gates that we talked about earlier to control how much of the old information in each slot gets retained.
Okay.
And how much gets replaced by the new information.
Oh, so it's like deciding whether to add a new book to an existing shelf or create a whole new shelf for it.
That's a great analogy. And what's really cool is that this gating mechanism is controlled by parameters that the model learns during training.
Oh, so it can adapt.
Exactly. It can adapt its memory updating strategy based on the specific type of data it's dealing with.
So it's not just about stuffing information into slots willy-nilly. It's about dynamically managing those slots based on what's important in the moment.
Exactly. And while the mathematical formulas might seem a little intimidating, the core idea is actually pretty simple. It's about finding that balance between holding on to important information and making room for new insights.
That makes a lot more sense now. So even though I might not be a math whiz, I can still appreciate the elegance of GSA's design. But let's zoom out for a second. What do you think this research tells us about the future of AI? Are we getting closer to creating machines that think like we do?
That's a big question. GSA definitely offers some interesting clues. Its ability to mimic certain aspects of human memory, like that selective retention and forgetting, suggests that we're on the right track toward AI systems that can learn and reason more like humans do.
So it's not just about processing information quickly, it's about understanding it in a deeper, more contextual way.
Exactly. And this has the potential to completely revolutionize a ton of different fields. Imagine AI systems that can understand complex legal documents or analyze massive amounts of scientific data.
Wow. Or even write compelling stories.
Right. It's pretty mind-blowing.
Did the researchers test GSA in any real-world scenarios?
Yeah, they didn't just stick to those synthetic benchmarks like MQAR. They also tested it on tasks that are a lot closer to how we use information every day, like question answering and information retrieval.
So the AI had to pull knowledge from multiple documents.
Exactly. It's like when you're researching something online and you have to go through websites, articles, forums to really understand the topic.
I do that all the time. So how did it perform?
It did amazingly well, actually. It really showed that it could handle the complexities of real-world information, Like it could generalize its learning to new situations.
So it wasn't just like a one-trick pony.
Nope, not at all. And get this. They even found that GSA could sometimes beat much larger models, which is pretty crazy.
Wow, so it's like sizes and everything.
Exactly. It's all about efficiency. And speaking of efficiency, we've talked about how GSA is designed to be super efficient, but did the researchers actually measure how fast it was, like how much computing power it needed?
Yeah, did they look at its speed and resource usage?
They did, and the results are really promising. The paper shows that GSA can be implemented in a way that's really hardware friendly, especially for those powerful GPUs that everyone uses for AI these days.
So it's not just some theoretical thing. It can actually run on the systems that we use today.
Exactly. They found that GSA was pretty speedy, both when it came to training time, like how long it takes to teach the model, and also inference speed, like how quickly it can process new information and give you an answer.
That's super important, because if a model takes forever, to, like, crunch data, it's not going to be very useful in the real world.
Yeah, you need things to happen quickly. And this focus on actually being able to use GSA like in a practical way is one of the things that makes it so exciting. It has the potential to change how we do a lot of things, but, like with any new technology, there are always limitations.
Right, there's no such thing as a perfect AI.
Exactly. So where might GSA not be the best choice? Well, the paper points out that it might not be the ideal solution for tasks that require super precise retrieval of very specific information.
Hmm.
It's really good at understanding the big picture and making connections, but it might struggle when you need to find that one very specific detail, like finding a needle in a haystack.
So it's like GSA can summarize a whole book and discuss the main themes. But if you ask it to find a specific quote on a specific page, it might have some trouble.
Exactly. But even with these limitations, the researchers see a lot of potential for future research, Like, they suggest exploring these hybrid models that combine the strengths of GSA with other approaches, or maybe even developing new training techniques that could make GSA even better.
So it's like they've built this awesome foundation, and now they're looking at ways to make it even stronger.
Exactly. And it's important to remember that AI research is constantly evolving. There are new breakthroughs happening all the time.
It's an exciting field to be following, for sure. Well, I think this deep dive into gated slot attention has been incredibly insightful. We've learned about this new approach that's changing how we think about AI efficiency and recall, especially when it comes to those long sequences of information that used to really trip up even the most advanced models.
We've seen how GSA borrows from the way our own brains work, using this clever combination of linear attention and a gating mechanism to achieve really impressive results.
And we've explored how this research is pushing us closer to developing AI systems that can truly understand and reason about the world around them, which opens up all sorts of possibilities.
So as we wrap up, I want you to think about the potential impact of GSA and other innovations like it in your own life. How could this kind of technology be applied to your work? What problems could it help you solve? What new opportunities could it create?
Those are some great questions to ponder. Thanks for joining us on this deep dive into the cutting edge of AI research. We'll be back next time with another fascinating exploration of knowledge and discovery. Until then, keep those minds curious and stay tuned for more.